Cloud. And now I'm going to turn it over to Gary AFAA, who can introduce himself. He is the amateur radio community coordinator that we have. So take it away, Gary.
Great. Thank you very much, Nathaniel. I want to welcome the new attendees today. I think come for a few weeks, and we hope you come for many. I think you'll quickly understand that we've got a broad range, not only chronological age, but range of experience, how long people have been licensed or will soon be licensed, but also a lot of broad range of experience in space physics and similar topics too. So I think, to me, that's been one of the most rewarding things of being involved with HAMSI, is just all the human experiences that you can gather and come along with. Okay, I'm going to share our screen. I think we've got a pretty busy agenda today. I think we'll get a lot done, and let me get over to my agenda slide. Nathaniel, maybe you want to start. I don't know if you've told this group about the recent updates for the HAMSI workshop.
Okay, yes, it's very exciting. Tim Duffy and DX Engineering have made a number of very nice donations to the HAMSI workshop. So this includes door prizes. We're going to have door prizes at the banquet. So DX Engineering has donated 10 $100 gift cards and a whole brand new ICOM IC 7300 as a door prize. So one of the lucky people at the banquet will win an ICOM 7300. They also were very nice to us, and DX Engineering also donated to the University of Scranton W3OSR Club a new ACOM 1010 HF amplifier. So when we finally get our new station on the air, eventually, we'll have an amplifier to go with it. So big thanks to Tim Duffy and DX Engineering. So let's see, then virtual registration is live. So both regular registration and virtual registration are both live. So if you want to come to the HAMSI workshop, you can still sign up to come in person. If you cannot come in person, you can watch the talks via Zoom. So you can go to the website and you can register to get a Zoom link, and that way you're able to not only watch them, but ask questions live. Workshop poster tracking. We can talk about that a little bit. So if you are giving a poster at the workshop, we'd like you to submit them by early next week. So preferably by, say, Monday, but if you need a couple of extra days, you can have a couple of extra days for that as well. And that will give us the time to actually print them and post them here. And so, Gary, you have the link for where people can upload them, right?
Right. That went out on a listserv last week, both for the posters and the presentations.
Right. But the actual link where they can upload their posters.
Oh, okay. Yeah. I've got to publish that. I wanted to talk about that today a little bit.
That sounds good. So we can get back to you with information on that. Any questions? On posters or presentations?
Yeah, one for me. I've copied the list of posters off the agenda, and I've hidden everybody's emails. I've got emails for everyone except the people in yellow. And
Okay.
rather than bother the 700 or whatever number of people it is on the main listserv, I was just going to go back and forth with this group, create an email group to encourage people and keep track of the posters.
Okay.
Do you want me to? I can put this in a Google sheet and share it with you, or maybe you could fill in the emails. Or I'm not sure how you could best get those to me. These are the seven or eight.
Yes, that sounds really good. Yeah, you can send it to share the Google Doc with me.
Okay, and I'll use their Scranton address for that, right?
You can actually share it to nafrizel@gmail.com.
That's what I thought may be better. Okay.
Yeah.
Okay, I'll do that, and then you can fill those in as time permits. So, okay, that's that.
Great. And some of those people may be printing their own posters, so we may not have to worry about it. So
okay.
It depends. When you follow up with them, you can offer to print the poster for them if they would like.
Okay, but we'll still eventually need the PDFs for the website, just,
That's,
Right.
yes, that's absolutely correct.
okay. All right, fantastic. Okay, that answers my questions in that area. Anything else on the mechanics of the conference? I know we want to review a couple of them, maybe one presentation and a couple of posters today, maybe.
I think that's it for the mechanics of the conference right now.
Okay, since I've got the floor, I'm gonna steal it really quickly. Just your opinion. So I did start working on a poster, as a side to my talk, and this is gonna be, I suppose, one of the, I would call one of the lighter weight posters. There's not a lot of science and technology in here, but I think
Yeah.
it would make sense. So if this is the right kind of format, to publicize the festival and each of the events, a couple of pictures and then some links.
Yeah.
Hopefully this would be adequate.
I think that looks great. You know, one thing you can do, you're welcome to use previous results. So if you want to take some figures out of my 2017 paper, and you can use that to show what we've seen in the past, and then you can talk about how I talk about in some of my presentations how we want to build on this. So you can talk about the questions that build on this. That might be a good way to make the poster a little bit meatier.
Good. Okay, great suggestions. That's just what I needed.
Yeah.
Okay, thanks.
Just a little detail, Gary, you have Eclipse misspelled in the title.
Oh, yeah, you would think spell check would catch that, but thanks, David. Okay. Close that up. We're done with that. I know Nick Hall Patch is with us today. Nick, did you want us to take a quick look at your presentation? Are you ready to do that?
Yeah, definitely.
Let me turn off my screen sharing. And
Okay.
want to give you an opportunity to spend some time on that. So why don't you go ahead?
Okay. All right.
And before we let him go, what I do want to do is I'd like to save some time at the end or at some point in the agenda to let our couple students, Mackenzie and Tom, talk about ideas how we might get collegiate amateur radio clubs involved and what they hope to get out of this.
Good, very good.
All right. So all I have to do is find what we're looking for. Okay. Sorry. Taking some. Must have opened the last damn thing. Oh crap. Sorry about. There we go. Okay. Okay. First of all, did you sort of hand out copies of this, Gary, to anybody who's present?
No, not at all.
Okay. Because I'd sort of thought that maybe that would be helpful because I mean this is a full presentation, so there's a lot of I don't want to take up too much time, but at any rate, so you can see what I've put on the screen. Is that correct?
Yep,
Mhm.
we're seeing it.
Okay, good. All right. Okay. This is just title page. Outline, it's just, like the totality of this medium wave DX is observed signal strength variations of broadcasters during past solar eclipses. And the use of solar software defined radios is now widespread in that group. People are regularly making, sort of very broadband IQ recordings over a megahertz. And they will be making recordings during the eclipse just so that they can sort of see what happened. It will be a historical record and they'll dig out more DX after the fact. And HAMSI could offer guidance as to how to make these recordings as useful as possible to the scientific community. And so what science would these recordings support and who will do the processing with the data? And could people sing out if they just say that doesn't make sense or something like that, or have a suggestion? Anyway.
I'll point out it makes a lot of sense. We at Dartmouth are actually doing this right now.
With medium wave.
Yeah. AM
Yeah.
broadcast.
AM broadcast bands. Yeah. Okay. And like I know that work has been done in the past. This is more a matter of people will be doing this without any sort of particular direction. And I guess the point of this whole exercise is, sort of suggesting ways that they can do the recordings so that they can actually be of more use to the scientific community. I'll jump forward in effect in the presentation without showing it, because most of this is verbiage. It's just simply that we actually had a number of people record during the 2017 eclipse, but it was completely found data. It was after the fact that it was realized that there was all these data sets. And so we gathered them up, and we actually did sort of zeroed in on one common station that was in all those data sets, and looked at the amplitude variations. But the thing is that, some of those SDRs had only been turned on a few minutes before the eclipse, so the signals drifted, and so there was no way that you could sort of look at any Doppler shifts or anything like that, because there was too much receiver crud on it. Anyway, so I could guess that's part of the outline, really. So I'll sort of just scroll through, like what I've got here. Historically, this goes into the the 1925 eclipse. They actually, Scientific American did a lot of got hold of a pile of sort of essentially medium wave listeners, and asked them to submit their observations as the eclipse went by. And as I said, during the 2017 eclipse, there were a number of DXers who actually did the same thing. And this is just there's 4 of them were zeroed in on because they were all near KSL 1160 in Salt Lake City. And so they had, so were able to record or shall I say, it was possible to derive the signal strength variations from the signals from the SDR files that they had recorded. And that's what this goes into here. And eventually those files actually ended up getting uploaded to the Zenodo repository. And it's fascinating how many downloads there have been from there. There's been, hundreds, literally, and some of them nearly 1,000 downloads from a single set of data from one person. I can't believe that all of those are, due to just DXers doing some DXing, because we tend to move on a bit. The DXers are, they're bright, shiny objects things. They play with things for a while and then they move on. So I don't know who's doing the downloading. So anyway, as I said before, this was found data. It could be better quality this time. What can we do to guarantee that it is better quality? I mean, one of the first things is just to make sure that people know that HAMSI is interested, and and this is where I'm moving into what I'm not as sort of cognizant about. It's the actual science, and these are 2 of the science sort of objectives. Is the ionospheric response symmetric with regard to the onset and decay of the timing, and how similar is the eclipse effect on propagation to that of the daily dawn and dusk terminator passages? Well, this can be done with this data, just with signal strength data, as far as I know. But this is where I need other people to tell me, well, is this useful, or is this just, fun, like I did with the KSL data. And so right there is a place where I'd want a response. What could be useful from this data? Has anybody got some guidance on this?
So I think what you're saying with the just measuring the amplitudes, if you're able to measure the amplitudes and the frequencies stably and reliably, and if you're able to keep track of where the receivers and the transmitters actually are and keep good track of the timing, I think that data can be used to help answer these questions.
Okay.
And the
Uh,
way that one way forward in terms of helping to answer these questions is we're having Joe Huba, he's one of our other invited speakers. He's running his ionospheric physics-based ionospheric model called SAMI 3.
mhm,
And he's going to be doing a prediction, a physics-based prediction and model of what he thinks the ionosphere will be as a
mhm.
result of the eclipses.
Yeah.
And we will make those observations, or I should say that those model outputs available to the community. And then you now have something where you can try and compare what you're receiving with what our prediction of the ionosphere is. And you're able to
Okay.
relate the physics together. Now it's tricky.
Okay.
So I know with the HF observations, the way we're planning on doing this is we're planning on using ray tracing with the FARLAP ray tracing engine. I
Mhm.
know that's very applicable to HF communications. I have less experience modeling medium wave propagation and modeling it through a numerical ionosphere the way I have with HF. So I think that the details of how you'd actually, use the observations and compare it with that model, that those are things that would need to be, we'd have to look at.
Mhm.
This is where it'd be good to get someone who kind of specializes in medium wave propagation and its relation to the ionosphere to kind of look at that, because every time you kind of change tools or you change frequencies in the physics, it's a lot of effort to go learn all of that. So one person can't reasonably look at all of these things and be an expert in all of these areas. So I think this is where we kind of have to identify someone who wants to be the AM medium wave science person or people.
Yeah, and that I think is, sort of the core of it, really. I mean, there's not a lot of sense in gathering data, however good it might make the people feel who are, contributing,
Right.
if nothing
Yeah.
much can be done with it.
But I should make some other points though. Even if we don't necessarily have someone identified right now, that
Mhm.
doesn't mean if we do a reasonable job collecting the data and we make it available, we can try to find someone in the future, or it may even be something we end up being able to fold in. So some
Mhm.
examples of this where this has happened, the reverse speaking network PSK reporter WhisperNet, they collect observations all the time. They hadn't been planning on using them for scientific observations, but I came along and I've been able to show that you can actually see traveling atmospheric disturbances in that data. And we now have a team that's going back, retrospectively looking at the observations for the past, say, 5 to 10 years. And we're actually using AI techniques and automated techniques to detect these traveling atmospheric disturbances in those data sets. And we have other people who are actually, like Mary Lou on this call, has spent a tremendous amount of time working with Diego to understand what sort of climatology is in there. So even though that data wasn't being looked at scientifically for a long time, we're now starting to get some really good results out of it. So I think if we are able to, we certainly do want to kind of wave the flag and say we're looking for someone to look at this. But even if we don't find anyone right now, I think we should still encourage people to take the data in as accurately as possible. And I think if you can break it up into 50 gigabyte chunks and stick it on Zenodo, then we know it's there. And it should be there for a long time. And once we get through the eclipses, then it's something we can say, I do think someone will step up and be like, I'm interested in this eventually.
Yeah. Okay.
Yeah,
And
if I might pipe up here.
Mhm.
As I mentioned, we're actually doing this though with Doppler shifts in the Northeast.
Mhm.
We've done it, and we're expanding our network out to the Eastern US.
Mhm.
And we do use locked receivers
Mhm.
because we're looking for tenths of a hertz Doppler shifts.
Yeah, and
But
I do address this a little later in this presentation. So
yeah, so we
yeah.
might encourage people to do it locked, but there are also maybe ways that we can back out the frequency data. But we don't analyze on the basis of amplitude, but I'm sure there's real science in there in terms of the absorption, especially with an eclipse going by and the changes in the D layer.
Mhm.
And I'm thinking that we should probably have you talk to who I work for, Jim LaBelle, and he will be, both of us will be at HamSci workshop, because he's the driver of our project
Okay, yeah, I've heard
at
the name.
Dartmouth.
Yeah, I have heard the name.
Mhm.
And I'll be attending virtually. I'll be very interested to sort of talk with them and, sort of get a better idea
Yeah,
of,
absolutely.
where this can dovetail in. As I say, I mean, these recordings are going to be made anyway. It's just out of, it's people are interested in doing this sort of thing. It's more a
Right.
matter
This is great, and it's just a matter of encouraging people to get as good recordings as they can.
Exactly. Yeah. Okay. And I think it's fairly easy to explain how to make, a good recording. Most of the people involved in doing this sort of thing are quite cognizant of, of stability and the effect of sort of the receiver and antenna and so forth on the quality of the data, and making sure they're consistent throughout the course of the eclipse and so forth. So it's just a matter of sort of reminding people to do that if they could, please. Thank you very much. Okay, and one of the reasons I go on about the amplitude is, well, first of all, it was based on Dr. Bamford's article from 1999, I think, because she did some of that, and we repeated the exercise with the KSL data. The thing is that it's now become really easy to get that amplitude data. So I'll go to the next slide. There's this software called Carrier Sleuth, which I think we raised once before in a meeting some time ago. And it can, show you all the 10 kilohertz channels on medium wave, or 9 kilohertz if you want. And you can see, obviously where the stronger signals can be found. And just simply by, sort of basically right clicking on a single trace, signal trace, you can get like a visual example of it, which, sort of is to the right here, or you can create a CSV file, which has, the signal strength in dBm versus time. And then you can do what you like with the CSV. And I mean, this is stuff that is actually, it was really laborious to do the KSL data because this software wasn't really available at that time. And this is just, really, you just follow directions and there you've got the data. So, it's something that actually, people who are doing the recording can do when they're looking at the recordings, and just say, hey, that's fun. Maybe you should look at this particular piece of DX or that particular piece of DX, and here's the traces from it, because it's something that anybody can do. They can't interpret it necessarily, but they can do it. Okay, so I guess the next thing is moving on to Doppler shifts, which is what you was talking about. And as you can see with this particular slide, that it's just an expansion of the previous slide, but you can see there's an apparent sort of splitting off of signal, and this is a signal at sunrise and at 1530 kilohertz. So it's possible to see these things, but other than the fact that it's visually interesting, it's not perhaps that much use as science in the long run. This is where things get a little more difficult. And as you say, this is using an SDR locked to a reference oscillator, but a number of them are available now, where essentially if you get yourself a Bodmer GPS and you put in the 24 megahertz or the 10 megahertz output, you've got yourself an SDR that's locked, and you can read the signals, so that the carriers accurately, and they're stable. So, again, this is available. Not everybody has them, but it might also be a bit of a kick for somebody to say, oh, I've been thinking about doing that. Maybe I should do it now. Okay. This is where you were talking to Nathaniel earlier. I know who's going to do the processing. There's a lot of data in there. And it's, but it's the sort of thing that, I mean, once you've got the data, you don't have to have it lined up right away, as you say, having somebody already to sort of dive in. Just having the data and having it available and having an idea of what's been happening within that data might be all we need to start with. So
I can tell you one.
sorry,
I can
go
tell you
ahead.
one group of people. I can tell you one group of people who might be willing to look at the data. I have, I teach these classes, like I'm teaching a space physics class right now, and I always have to do some sort of a project or something for the class. So if all the data is up on Zenodo, then I can tell the class, I'm like, hey, look, there's all this Eclipse data on Zenodo. Go get it and try to look at it. And so there's at least one group of people who can start to look at it.
Yeah, and again, if I'm happy to act as the sort of the central point to gather this data, which is what I did before in 2017. And we could, sort of process it through Carrier Sleuth, and so essentially you already have a snapshot of what's been happening on each channel. That's something that somebody like with my capabilities can do, or in fact, the people who actually record the data can do as well. So it's already, sort of, can visually look at it and say, oh, that's interesting. Maybe I should look at that a little further. And that's where things are radically different from 2017, is just being able to say, this is a simple way of, sort of understanding what you've got in front of you.
Well, I'll just point out that we have software that runs on Raspberry Pi that does the FFT processing in real time.
Yeah, I guess in the sense that, the real time, like this is not real time. This is recorded data.
Well,
so
it doesn't matter. I'm just saying that it runs fast
It's-
enough. We can actually run it real
Nick,
time.
I do really recommend talking with David McGaw more and and Jim LaBelle, because they do this all the time scientifically. So
okay. I think that's that's pretty much it in a nutshell. I can say bring up an example of this, which I just happened to stagger. This is from 2017, and this is where you just click on something and graph as a signal, and bang, you've got an idea of what it looks like, in numbers, and this is going to be the other side. So you can see there's two signals, one to the west, one to the east of his site. And, you can see the variation in signal strength versus time. It's, very, very straightforward. So anyway, I say I'm going to be attending virtually. I'd be happy to talk more with you. I did send you an email a while back when I was first getting into this, but I never heard anything back. So I don't know, maybe got lost.
was that to me or to some? Was that
sorry, to David. Yeah.
Okay, to David.
Yeah. Because I do understand that you're sort of in the same, in the same area of what's being done here.
Oh,
and some guidance is very welcome.
Did you send it using this email address?
No, it's just just the address that I got from from Hamside.
No, I'm just seeing. I'll see if
it was some time ago.
I got so
now.
much email; it's easy for things to get lost.
No, I understand. It's anyway, that's neither here nor there at this point. But like I do understand that you have the expertise to sort of offer some guidance here, because I've been sort of flying a little bit blind.
We're very interested in having more people take data.
Yeah. Okay.
Okay,
So essentially, I think we've probably taken up enough time. At least as far as I'm concerned. If anybody else wants to dive in, please do so. But you know, that's pretty much the bulk of it. Nathaniel, I mean, when, like, you're going to want a copy of this, you know, that I assume that people who are presenting virtually are going to be running it from their own machine, but presumably, you know, you want a copy of it as well. Is that correct?
Yes, I'll get in touch. I'll be sending out a link where you can upload to.
Okay, good, great.
Yeah, Nick, I
Okay.
did not receive your email, so it went to the
Okay.
great big bucket in the sky. Try
Okay.
it again.
All right, as I say, it was
I'll
some
have to
time
write
ago,
one
and
in
I've done a lot
memory.
of stuff since then. So, but
Yeah,
I will
unfortunately,
dig it up.
unfortunately, Dartmouth's Outlook system will swallow emails if it
Yes,
doesn't
yeah,
like
no,
them.
I'm familiar with that. Okay, yeah, so I'll dive out. All I have to do is figure out how to stop sharing my screen here.
Would it be possible for protocols for appliance operators like me that would want to record data to use the October annular eclipse as sort of a practice run for the real thing?
Well,
And
yeah. First of all, I mean, for me, the whole point of the two eclipses is that, yeah, the annular eclipse is really important, because I think from radio reception point of view, there may not be that much difference, you know, and you know, that's so I think we should definitely be going all in there, you know, and just trying to fine tune it for the real thing. But what is it you're thinking of doing yourself?
well, I've got the SDR Uno and I've got the Bodner oscillator.
Okay.
So that's,
as-
that's one aspect there. The other is that wherever Sky and Telescope says is the most optimal viewing point
Mhm.
in October, I'll be there
Okay.
with the radio
Okay.
and operating portable.
Yeah,
So,
well, no, that would be great to, you know, sort of have you as part of the data set. When you say SDR Uno, that is the software. What is the actual hardware that you have?
well, let's see. It's one of those two radios, the little palm-sized radios that.
Yes, that can be locked. Yeah,
Well, the big question is it a single or dual channel version?
yeah.
Mine's dual.
Is it?
Yeah.
Okay, yeah,
So it is the RSP Duo.
yeah. If it's got the two channels, yes. And that'll be interesting. Because
Yeah,
I don't
I'm
have
just
that. Yeah.
bringing that up because with the Duo, you could run two different bands. You could run the broadcast band and then HF band at the same time.
Yeah, mine's an RSP Duo, dual tuner, SDR Play.
Yeah, yeah.
Right.
Okay.
Perfect.
All right. Okay.
And
Well,
you have the Bodnar to lock it. So
yeah. Yeah.
You're our guy.
Exactly. Yeah. Okay. Fascinating. Well,
Right.
Keep in touch. You know, we'll do we'll do dog and pony show at the workshop anyway, and you know, hopefully, we'll be doing publicity after that in terms of getting people interested. But obviously, the people who are involved with HAMSI are welcome to attend as well, so to speak. Okay. Back to you, Gary.
Okay, good. I'm glad we had a discussion. Hope that helped a little bit. I think other thing to keep in mind too is if people want to get together and meet outside of our normal meeting times, I believe some of these Zoom links on the page, Nathaniel, are pretty much active all time if people wanted to use them, if you're not using them, obviously.
Yeah, certainly, like, they are categorized, so if you want to hop on the solar eclipse one at any time, you know, you're more than welcome to. Go for it. I do get an email when people sign in, so like if you sign in, I'll get an email, but that's okay, and I tend to ignore those.
So that's good. That's just another opportunity for people.
Unless there's someone I want to talk to, then I might hop on really quickly and say hello. So. But yeah, no, that's really good.
I just chime in here. I have about 50 sites that will be making those IQ recordings. They could be doing medium waves. You know, they're all going to be about a 30 millihertz or better frequency, accuracy, and stability. I'm planning to do most of them on WWV, but you know, we can do other. They'll be doing all the ham bands as well. So there'll be a tremendous volume of data through from my sites that could be fed into the analysis. So if there's going to be discussions on this formats, I'd really appreciate if someone would include me so I can know where to how to format and feed the data that we'll be gathering.
Yeah, okay. Again, I don't know what else is, on the agenda today, but, definitely, we should discuss this further because there's,
Yeah, if you're going to have a meeting,
yeah.
I just say include me on your email list, and I'll try to participate and
okay.
go into
Yeah, all right.
greater depth.
Mhm,
So
all right. Yeah. Okay, thank you.
Okay, good. And that's obviously one of the reasons for these meetings is to get people together. So that fosters more and more thought. We've got about 15 minutes left. I think we should take a few minutes and consider the college club participation in the upcoming eclipses and stuff. I know Mackenzie, that was one of your questions, and Tom's now here too. So I know we're missing a couple of our representatives from Case Western Reserve. They're out in Colorado giving a talk tonight, but I'm not sure if we've got any other information on what the various college clubs will be doing for the eclipses.
Well, right now, I think the main thing that we have, the easiest way to join in, of course, is the Solar Eclipse QSO party, because that's the kind of the contest-like version of operating that is contributing to science. We also do have other options that are a little bit more, should I say, organized scientifically, or more along lines of a traditional experiment. But I guess maybe Mackenzie, maybe you can start by saying what you're hoping to get out of this and what you'd like to do, and then maybe Tom can talk about things too. I think most people here know, but maybe you don't know, Mackenzie. We are at Scranton, we're a very new collegiate amateur radio club. We don't even have a station yet, but we're building one. So we're building a station that should be on the air by this summer. So our students don't necessarily have a lot of operating experience yet, but it'd be also interesting after you talk to hear what Tom is hoping to get out of this and how he thinks the students might be able to participate. So go ahead, Mackenzie.
Okay, so I think it would be a very fun contesting experience. First of all, that's really why I'm interested in doing it. And we actually do have a station at ODU already established. So thankful for that. Also, I think it would be really interesting to see how the ionosphere behaves during an eclipse. Obviously the conditions would probably be a little different, and that's just really the main thing I would be interested in. But also, I'm a big contester. I love doing contests. It's one of my favorite things to do, and I think this is also really special, and it's just really an awesome opportunity to be able to help you guys with getting that information. So I'd love to just be of help at any point for you.
All right. Hi, everyone. Again, my name is Tom. I'm new here, so I want to just, say hi again. So I think one of the major things we'll all gain from this is learning how to collect helpful data. I feel like that's very important for like us, us amateur radio clubs. So when there are future events, we know exactly how to get this helpful data. I also think this, in like collecting helpful data, and maybe like if there's like online resources to collect helpful data, like other hams who, while they know how to like make communications, they're not the best at getting the data, like they'll educate them on better data collection. I think that the event will also bring new eyes towards ham radio. Hopefully we can like post more media to to bring these new eyes into it. What else? And I also think like the data will be very helpful in understanding, like Mackenzie said, the ionosphere, and have a better understanding of space physics as a whole.
It's I appreciate what you both are saying, because if you think back a certain number of years, most communication was terrestrial from point to point across some 2 points on the Earth. But now we're to the point where with satellites, with Starlink, with GPSs and stuff, a lot of our communication actually passes through the ionosphere. So to understand how it works, how it reacts, and how these events affect it really has a profound impact there. I really think it does.
Nathaniel, I have a comment.
Yes, go ahead, Ward.
Okay, thanks. Gary, that was a good observation that our modern communications go through the ionosphere, but they don't, they aren't traditional ionospheric propagation. And so maybe there is an angle for measurement of the path through the ionosphere. I think we have total electron content as one of the measurements. Perhaps there is some other measurement, I don't know. At some point, this is sort of a sidebar. There is a satellite allocation on 40 meters that has never been used as far as I know. And it would be of interest to have a CubeSat up during one of these solar events that would transmit a reference signal on 40 meters and be measured on the ground. That's an idea, or any of the HF bands actually. The second point is that college clubs tend to operate on a semester basis or quarter basis, and I think it would behoove us to start some kind of a communication process, possibly coordinated by one or more clubs, to let all of the clubs know that this is going to be happening during fall semester this year, so that you can start planning for it now. And then there's the full eclipse in spring semester of the following year. So if we can start a conversation within the college clubs, and perhaps one or more of the college clubs would take the lead on coordinating and disseminating information to the other college clubs, this would be something, I think, more amenable to the college clubs and more interest to the college clubs, since they are going to look at this differently than individual amateurs. But there's an awful lot of STEM and research information to be gained. So it's a different kind of a program, but I don't think we have to change the events, but we may need to augment the way that we communicate what the event is about and how to go about it. Hope that made sense.
I think so. One way we can do that is by working with Bob Inderbitzen and Steve Goodgame and the Maluzis over at the CARP program.
Mm-hmm. Yeah, Steve Goodgame would be the person at ARL that I would talk to, and then go through the Collegiate Amateur Radio Initiative and start seeing if we get a couple of clubs that would like to step up and be the lead source of information for college clubs.
Comment. So I actually have a database of a lot of the amateur radio clubs for colleges on my computer. I can send that to you if you'd like. I can also contact a lot of the clubs because I am able to contact them via social media. If you would like me to help you with that, I would love to.
We'd love to have your help.
Okay. Yeah, I just wanted to let you know. So
Yeah,
Sure,
if you
kind
want
of a mailing list or groups.io or whatever is the approved or the most common way of building a community would be great. Sorry, back to you, Nathaniel.
Oh, no, that all sounds really great. And Mackenzie, are you already tied into the Collegiate Amateur Radio program too?
yes, sir, I am.
Okay, great. So yeah, we would love to have your help. And if you and your club kind of want to take the lead on that part of it, we'd be grateful. If you just want to help out in a more minor and not taking lead, but still helping out, we'd be grateful too. So however you'd like to do that, we'll help you do that.
Yeah, I'd love to take the lead. I'd love to help you guys out in any way I can.
Okay, that's great. So I'd like you to meet Gary more formally here. Gary's our amateur radio community coordinator. So he's the one that you'd probably be working most closely with in terms of, what messaging to get out and how to send that out to people.
Yeah, Mackenzie and I have been going back and forth on some whisper topics for the last week or so too. And I also want to make a note that she's also a satellite operator, so things things are fitting together pretty well here.
That's awesome. Good job, Mackenzie.
Yeah, there's always a concern that people get licensed and they don't do much with their tickets, but obviously, Mackenzie, you've got your fingers in a couple of different things, and that's the whole point of the hobby. There's so many different directions to go, and to try them and taste them all is definitely a good thing.
Mackenzie, do you want to come to the Hamside workshop in person?
Where is it located at?
It's here in Scranton, March 17th and 18th. We can figure out how to pay for you.
Okay, I'd have to check my schedule, but I can email you if I'm able to come, if that's okay.
Yeah, if you are able to come, like your schedule, we'll figure out how to cover your costs.
Okay, thank you. I appreciate that.
You're welcome. Thank you. Well, thank you for volunteering. We really appreciate it.
Yeah, and especially somebody that's tied in on the social media side of things, which I am definitely not. So that in and of itself would be a big help.
Yeah, a lot of the people you see on the Zoom call here will be there in person. So Gary's going to be there. Dr. West is going to be there. I'll be there. Tom's going to be there. David McGaw, Rob Robinette. So you'll get a chance to meet all these people in person.
All right, good. Well, there was one other thing I wanted to cover that'll only take about 30 seconds. We talked about media coverage and whatnot, and a few weeks ago we said we suggested we put a media hits thing on our website, and I've got something up on the test site. So let me just show you that, Nathaniel, if you think this is the right format. There, so that's what's up on the test site. It's a little less formal than your publications and presentation tab.
I think that's great.
Okay. All right, I'll move this over to the production site and I can maintain it going forward. That's not a problem, but this is what we'll go with. That's perfect. Thanks.
Thank you.
Okay. Getting close to 5 o'clock, got a few minutes left. Is there anything else anybody would like to discuss for today? Questions to be asked?
Harry, I agree. You ought to shut the thing down. We've been here an hour, but if anybody wants to hang around afterwards, I did run some experiments with a buddy of mine up in Abilene. It's about 200 miles north of here on the TDOA stuff. And I do have some preliminary results to show you if you'd like to see it.
Yeah, it sounds interesting.
Yeah,
I agree.
I can stick around for a couple more minutes.
It won't take long.
Let's go.
Want to do it now?
Yep.
Yeah.
Can I share the screen?
Mm-hmm.
So let's see, I want my desk. Oh, I can only do one at a time. Okay, let me show you a couple of things first here. Oh, I do have the whole screen, or do I? Yes, excellent. Can you see this?
Came over and meowed at
Yes.
me.
Yes.
You can see the waveform up on top here.
No.
And my cursor.
We're looking at Excel at the top, just the text.
Oh, it's just the thing in green, isn't it?
MSI SEQP TDOA waveform.
Okay, well, the waveforms that we send out consists of, first of all, there's 5 repetitions of a 1 cycle burst of 1.5 kilohertz, just single cycle audio burst. That's useful because it gives you a feel for what the time difference of arrival is just directly by looking at it. And then there's several different chirps. There's 5 repetitions of 100 hertz per millisecond. That's 0 to 5 kilohertz in 50 milliseconds. And then these get longer. There's 50 hertz per millisecond, 25 hertz per millisecond, 10 hertz per millisecond, and then finally some of the fast ones concatenated up-down chirps. So let's see, is there a way I can go? How do I change what we're looking at? Oh, then this other graph down here, you go grind through the math of a round earth model on 1 and 2 hop modes. They're locked together. If you can measure the time difference of arrival across this axis, and then here's geometric height going this way for ground distances of 3,000 kilometers, 25, 2,000, and so on down to 250 kilometers. And I'll show you when I put the real data up here that we actually measured about a 1.6 millisecond time difference of arrival. So right here is 1.5, 1.6. You follow that line up. Paul is 200 miles. It's 317 kilometers. So here's the 250 kilometer line. Here's the 500 kilometer line. So right about here is his location at 3 something. And that corresponds to about 270 kilometers of layer height, F2 layer height, which for this time of the morning, which is about an hour after sunup, it's in the ballpark. I've got to pull the ionosonde to find out, but in previous ionosondes I've looked at for that time of day, that's not bad. That usually it's like up around 300 kilometers at night, maybe higher, and then by the time the sun's good enough, it's down around 200. So it's in the ballpark. You know, this isn't really anything better than 2-place accuracy. Okay, so can I click that off? Yes, that did that. Now I want to look at this one. Okay, this is the actual data shot. I am screen sharing. That's good. So here's his noise floor. Here I started transmitting. You can see his AGC kick in, and here are those first 1 cycle bursts right there. Then here is the first 5 fast chirps. Then the next slower chirp, the next slower chirp. These get longer too. Next slower chirp, and then the slowest one. Then finally here is those fast up and down chirps. It's got to be around here somewhere. Okay, so I should be able to zoom in. Oh, good. Zoom in on this. Zoom in again. So here's the 2 1 cycle bursts. It's good because you just look at the time difference here and you can see it. You can see this up here, can't you?
Yeah.
Okay. So these are 1 milliseconds per division here, 2 milliseconds per big division. So from here to here is on the order of 2. Let's go to the next one. Look at this one. Same thing, one millisecond per big division. So there would be 1. If you call this, that's the problem with the 1 cycle burst. How do you tell exactly, does this peak really correspond to this one? You look at enough of them, you can almost convince yourself it does. The chirps are better, but at least this gives you a feel. So this would be like about 1 millisecond from here to here and about another 0.6. So yeah, it looks like about 1.6 milliseconds.
You can see what I'm comparing here is the ground wave versus a sky wave. Is that what I'm saying?
These are both sky wave, but it's 1 hop and 2 hop.
Oh, okay, gotcha.
And that's what this whole thing does. Is the time difference of arrival between the 1 and 2 hop modes. So these are the chirps. When you send out a chirp and you receive both the 1 and 2 hop modes, they both appear simultaneously in your receiver passband, but because they're displaced in time, they beat against each other. And in that little poster paper I sent, there's a formula that lets you compare it or actually find out what the time difference of arrival is. So what you do is you can see this beat pattern here. You would look for example, a null to a null or a peak to a peak. And let's spread this out a little bit. So this is 5 milliseconds per big division. So from here to here is 5 plus a little more is about a little over 6 milliseconds on the period. So what you do is you take that number, multiply it by the sweep rate, which in this case is 100 hertz per millisecond. And then you take the reciprocal of that to get the TDOA. So you've got like 1 over 6.2 times 100. And that comes out to be also about 1.6 milliseconds. And that agrees pretty well with what you saw from the 2 1 pulse things. And that again corresponds to about the 270 kilometer layer height. So it looks like the measurements are more or less working. They don't all look as pretty as this, obviously. We took another data set a few days later This was done on 60 meters, channel 4 and on 5 megahertz. We also took some data on 75 meters. I was using my 7610, just sending the recorded waveform out USB to the radio. Paul just punched his record button on his ICOM 7300 to record this data. And then he sent me the wave files. Now this is 0 to 5 kilohertz. So it starts here. But now remember, we're going through sideband radios, right? And they have pass bands of what? Depends on how you set it up. 200 or 300 hertz at the low end, maybe 2700 hertz at the high end. So you don't see anything at first. Finally, you've got enough audio frequency to get into the pass band. Now you're starting to get the waveforms. And then you don't quite get all the way to 5 kilohertz either, but you get enough. You get enough. And again, here's the next one. You would look either peak to peak or null to null. Same answer, about 6 milliseconds. Then later on, you get to the next slower series of chirps. See how they're spread out farther in time. The math still works out the same. So anyway, I'm encouraged. This is pretty much doing what I'd hoped it would do. They're not all this pretty. There was gosh, we had like the A index was up like 94 the other day from that solar storm that we had from the flare. So anyway, that's the data. The idea is to take data periodically during the course of the eclipse. And before then, I will have taken data during a sunrise and during a sunset, as Mary Lou suggested, so that, because the same thing happened, sunrise and sunset, it's just that the eclipse makes it all happen in a very compressed time scale. And hopefully we'll be able to watch that layer height change and then compare that to an ionosonde, like around here, the Austin ionosonde would be a good one, and compare the two measurements and see how we did. But this is what the data looks like.
That looks great, Steve.
Yeah, that's pretty interesting.
I have gotten busy. I've got to go on a field trip starting this weekend. I'll be gone for about a week and a half. I'll be back maybe March 12th, 11th or so, perhaps. So I've just gotten busy. I apologize. I would have liked to have had a lot more of this data done by then.
I think this looks great. Thank you.
Here's the slowest chirp. And then finally, here are those last 5 fast up down chirps concatenated together. And you can kind of see the same thing happening up, down, up, down, up, down, up, down. Actually, I'm not sure we need all these. I'm pretty happy with just these first parts of it myself. I was a little worried about getting 2 hops on that short of a range, but it's pretty clear that we did, and it even more or less makes sense with data I've seen where the layer height should be for that time of day.
This looks really beautiful, Steve. Thanks.
Thank you.
I agree. Thank you so much, Steve. This looks great.
I'll get these written up and sent to you.
Thank you.
Thanks. Interesting.
All right. I think we are at 5:08 now, p.m. Eastern. I guess a couple things next week. I think we're still on Eastern Standard Time next week, right?
Yes.
It's the week after we go to daylight time. So next week is our normal time. Then the week of the Hamsci workshop, we will not be meeting because we're all going to be getting ready for Hamsci workshop. And at least for me, I'm not going to be on the week after Hamsci workshop because I need to recover. And I have some family members that are having knee replacement. So I want to make sure that I'm there for them. So yeah, but otherwise I think this is great.
Yeah, good meeting today. A lot of input from a lot of people, which is what we like, so.
Thank you. Yeah,
Thanks.
Mackenzie, let me know if you are able to come and if you want to come, and we'll work on the arrangements for you.
I definitely will. Thank you.
Thank you. Thank you, everyone. 7-3.
you.
All right, have a good week.
Bye.
Here.
All right.